Donuts. Howdy, folks. Thanks for checking into Mr. Ulrich's Land of Biology. I, of course, am Mr. Ulrich, lover of donuts. In this notes cast, I'm going to introduce this idea of the categories of macromolecules that make up living things. We've been talking about functional groups and how functional groups can impart their chemical properties onto the molecules that make them up. And now we're going to talk about taking whole molecules and putting them together into making huge molecules. And I'm showing you these donuts for a reason. I'm not just torturing you with donuts, virtual donuts that you can't eat, but we do have the saying, you are, you eat. And if you only eat donuts, it's not like you're going to turn into a donut. The problem, of course, is that you're only going to have those parts of donuts to use as raw materials to make all of the lipids and the carbohydrates and the proteins and the nucleic acids that make up you. And well, we're not so worried about the lipids and the carbohydrates. It's those proteins. You're not going to have the resources that you need to make all of those proteins that are you. If we're going to discuss macromolecules, we really need to take a moment to talk about polymers, which are kind of a basic structure that is common to many macromolecules. Polymers, just like the prefix poly indicates, are many. They're made of chains of many repeating units in a row. I often compare them to choo-choo trains, rather simplistic, but it's kind of cute. That means that one car of the train would be a monomer, mono for one, and two cars would be a dimer, and three cars would be a trimer. And there are oligomers, which are several, and when we start talking about protein structure, we can talk about hexamers and things like that of insulin. Sometimes those are not in a chain, however. The important thing is that these chains are bonded together covalently, so that there are covalent bonds between the monomers. Speaking of those covalent bonds, how do we actually make those bonds, those chains of repeating units? These are going to be condensation reactions, usually between a growing polymer and an adding monomer that's being added on. In the case of living things, it involves taking a water molecule out. One side of the growing chain provides the hydroxy, the other provides a hydrogen group. Those together make the water. Because we're removing water to put things together, it is literally dehydration synthesis. Now, this is not going to take place on its own. It would take more energy in order for these molecules to just clunk together with just the right trajectory, just the right amount of energy to knock the hydrogen and the hydroxyl group off. So it's not going to happen on its own, but if we add things that will hold the subunits in place at just the right angles and put just the right bond strain on those angle strain on those bonds, we can break the bonds a lot easier, and this is going to be done through enzymes. When you go to your favorite restaurant that isn't a fast food place, one of the earlier questions you're going to get is, do you want a glass of water with your meal? Do you want water with that? They're probably not thinking about the chemistry of digestion, but since digestion is going to involve breaking those bonds that we were just talking about forming during dehydration synthesis. The process of digestion involves hydrolysis, which is just that, the reverse of dehydration synthesis. It's taking water molecule, breaking that into the hydrogen and the hydroxyl, and using those to kind of stuff into that bond between the two parts of the polymer and break that apart into now two separate molecules. Sometimes this even uses the same enzyme as dehydration synthesis in a reversible reaction. All right, well, we'll keep it short and sweet and end it right there. I have more videos coming up about the carbohydrates and the lipids and the proteins and the nucleic acids, so we got a lot more to do, but we'll save that for future videos. If you have any questions or comments or concerns, please, as usual, drop them in the comment section, send me an email, put them in Google Classroom. You know how this works. Other than that, I hope to see you in class real soon.